Now we have discussed about what is equilibrium of forces. Now let's take an example that has been given in your NCERT book and let's try to solve this by understanding equilibrium of forces. The question is in such a way that this is a rigid support and this is a rope. This is a rope, and from that rope a object is hanging. Now what happens is that a force of 50 Newton has been applied to this point of the rope such that the figure becomes something like this. The figure becomes something like this. Now the question that has been asked is that what is the vertical angle? What is the vertical angle? Either this angle or you can consider this angle. And these two angles are same since we are drawing the normal to the x-axis. Normal to the x-axis. So this two line becomes parallel. And when these two lines become parallel and a transversal is joining these two lines, so the alternate angles are equal. So it does not matter, and plus I advise the students to not get confused, where you can see in different books they have taken different angles of reference. So these two are actually basically the same thing. So let's proceed to the question. The value is given in such a way that the mass m is 6 kilo. Acceleration due to gravity is 10 meter per second square. The length of the rope is 2 meters. Length of the rope is 2 meters. We need to find the angle. So in order to do this, we need to draw a free body diagram. Now what you can see is that this is a rope, and another condition that is given to this rope is that mass of rope is equal to 0. That is, we are considering the ideal situation. We are considering the ideal situation where friction is 0, pressure due to atmosphere is 0, and the mass is 0. Now what happens if the rope had mass? You will have this in your later chapters, but now what you need to know is that, say suppose the rope had mass, so if you are considering tension at this point, the resultant tension will be because of this mass plus this extra mass, that is because of the length of this rope, this particular length. Now if you look at this point, the tension that is experienced over here is because of this rope, this particular rope, the length for this particular rope, because it has mass, so it has some weight, and this weight will pull down this particular point. So the tension that has been experienced by this point will be because of this and the mass m. So now you see that there is, because of variable mass, there is variable tension that has been experienced in the whole of the rope. So right now we won't be concerning with this variable mass, we only will be concerned with a ideal rope. So how will you approach this question? This rope is experiencing a tension T. Now when this force has been applied, this applied force after some time, after making an angle of theta, stops. Now what does that tells us? This tells us that if the rope is stopping after a point, that is in a free state, in equilibrium state, that is the rope is stopping, that means the force has been nullified, that is a force of 50 Newton that is going over here is being adjusted with a force of another 50 Newton that is going in the opposite direction, and only then the whole system comes into equilibrium. Similarly, if this object of mass 6 kilo So the weight, if this is mass, the weight is mg, that is force that has been applied due to this object. So this is mass 6 into acceleration due to gravity. What is acceleration due to gravity in the surface of the earth? That is 10. So a force of 6 Newton has been applied downward and it's in equilibrium. So equally a force of 60 Newton should be applied upward by this rope to maintain this particular position. So this is what we can understand from this figure. So this particular rope is making an angle of theta. This particular rope is making an angle of theta. So we are breaking T into its respective X and Y components. Now I urge the students to please refer to the previous videos where we have explained quite elaborately how to break this into components. So this is your T sine theta and this is your T cos of theta. Now according to the question, T sine theta, this is your T sine theta. This is your tension, that is tension T that is experiencing over here. This particular tension is equal to T sine theta is equal to 50 Newton and T cos of theta is equal to your 60 Newton. This is equation 1 and this is equation 2. Now you need to find the angle. This is theta. So by calculation I know if I divide equation 1 by equation 2, I will get T sine of theta divided by T cos of theta is equal to 50 Newton by 60 Newton. This is N and this is N. T gets cancelled. So this becomes sine theta upon cos theta is equal to 5 by 6. Now this is nothing but tan theta. Tan theta equals to 5 by 6. Therefore, theta is equal to tan inverse of 5 by 6. And this is your required angle. So in this way, we can understand the equilibrium of forces by drawing a free body diagram. Now let's come to the next topic, that is friction. Now I have tried to explain in this particular video friction in a much simpler way, because what we see is that students often get confused with the term friction plus the direction of friction. So if you want to understand something, you just need to relate this with your real life examples. Say suppose you have a block of mass m which is in the ground. Now you are applying a force of F over here. So you see that the block is not moving smoothly. The reason because the ground is rough and the surface in molecular level is also rough. So this two gets connected over here and it opposes the motion of the body, and therefore a opposing force. Now please keep in mind, opposing force is generated. And that particular force is known as friction. So if you want to give in an examination the definition of friction, do come. So what you can say is that a opposing force that is being generated when a body moves or tries to move. Now please keep in mind, when a body moves or tries to move, when coming in contact please keep in mind this should be your physical contact. When coming in contact with another body, that type of resistive force, is friction. Now you can use this definition in your examination. Now what factors does F depends upon? That is the frictional force F. I am denoting frictional force with small f and a force that I apply with capital F. Now what factors does F depends upon? It depends upon the surface, that is how rough or what is the frictional coefficient of that particular surface. That is the factor on which frictional force depends. The other frictional force is that what is the normal force that has been applied? What is the normal force that has been applied to this particular surface? Now let me tell you something with the example. I'll explain this point with the example. Say suppose your surface is rough. Usually you see the surface to be smooth, but if you magnify the surface, you will see that this surface is rough. And if I put another surface on top of this, so these two are opposing its motion. Now if this is gently placed, I can easily push this. I can easily push this particular object. Now what if I am applying a force, if someone is sitting at this block, so this becomes heavy, so this too is compressed more, this is pushed more in the ground, so this is pushed more in the ground. First we had some gaps. Now since we are applying a force on top of this, these two objects are more tightly placed, that is the rough surface are more tightly compressed. So the pushing force that needs to be applied to move the object is much greater. So what we can understand is that we have termed the word normal, that is this particular object, this particular frame of object, what is the amount of force this particular object or this reference point is putting in this surface. That is the normal force that the mass is giving to the surface. This is known as the normal force. So the another factor in which the frictional force depends is your normal force and your coefficient of friction of the surface, that is both surfaces, both the object and where the object is placed, both surfaces. This is known as coefficient of friction. So these are the factors in which friction depends. Now let's move into different types of friction. That is, one type of friction is your static friction. This is known as static friction. Static friction, when the body is not moving, it still has a friction that is holding the object. For example, in an inclined plane, you see that some boxes do not fall. Some boxes do not fall up to a certain angle. So that is because of the static friction or the frictional force that is holding the object. That is, it's not allowing the object to move. The second one is your impending friction, that is your sliding friction. This friction comes into play when the object starts moving. Now, someone may say that static friction and sliding friction should be equal. Now, I've often come across this doubt, that saying that they don't understand the difference between static friction and sliding friction. This is sliding friction. Now let me explain to you what is the difference between a static and a sliding friction. Now when an object is at rest, in order to move this, we need a force which is equal to its static friction. In order to move a body from rest to motion, a static friction comes into play. The initial force that needs to be applied. After the body starts moving, sometimes it may so happen is that the force required to keep the body moving becomes less. That is, the sliding friction after the initial motion, the body experiences just the sliding friction. That is, when the body is sliding, the friction that is the body that is being pushed back is due to the sliding friction, and the initial motion, the initial force that has been required is because of the static motion. And that is the reason why these two, even though it may sound same, but these are different. So let's understand this in a mathematical way. Now when we talk about static friction, as you can see that this is a body. Now you have applied a force, the body tries to move but it's not being able to move. The reason is because it's stopped by the static friction. That is, we can say that impending motion has been stopped. Impending motion that was supposed to happen was stopped. That is, the impending motion has been stopped. So mathematically what we can say that Fs is equal to mu s, that is coefficient of friction. Coefficient of friction into n. Now what is n? N is the normal force. Normal force that is the object is putting. This is the object and this is the force that it's putting on the ground. This is the normal force. Now if I add another force, say F, so the normal force will become this plus n. That is, the resultant normal force will become mg plus n. So this is how you can understand static friction. Now in order for the body to move, the applied force should be greater than us into n. That is, the applied force should be greater than this. The applied force should be greater than this. Now the maximum value of static friction can be over here. The maximum value of static friction can be over here. Now if this particular force crosses this value, then the motion starts. Now this was all about static friction. Now let's come to your sliding friction. The sliding friction can be written in such a way that sliding friction has a coefficient of sliding friction, that is a kinetic friction that you experience into n, into the normal force that has been applied to this. So what Fk? We have written Fk. This is sliding friction, or you can simply understand this as kinetic friction. So kinetic friction, you can understand this as a frictional force that opposes relative motion between surfaces in contact is called kinetic or sliding friction. So when the body starts moving, mu k is your coefficient and f of k comes into play. Kinetic friction, sliding friction can also be known as kinetic friction. So this is your another term. So when the body starts moving, say you are applying a force of F and this is opposed by mu k into n. So the resultant force F resultant is actually equal to F minus into n. So the acceleration will depend upon this resultant force. Resultant. So this is how we can understand static friction and sliding or kinetic friction. Now I have used the term this over here. This is very important. The reason why, because we know the static friction, that is, say suppose we are pushing F. We are pushing the object with a force F. Now the friction that this body experiences depends upon F. Say suppose a force F1 is being given, so the static friction will give a opposing force of F1. The magnitude will be same. If this is F1, the static friction will also give a force of F1 to keep it from moving. But what I want to focus or amplify is that the maximum value that the static friction will give to the opposing force is this. That is, the maximum value is always coefficient of static friction into the normal. So if a force of F is beyond this force, then the body starts moving. Or else, say suppose if I give a force which is lesser than mu s into n, then the opposing or the static force that is applied to keep the body from motion, or what we can understand is that the static force that the frictional part of the body is giving is simply your F. It need not be mu s into n. All the force when we are applying, say suppose F1 over here, the resultant force that is being applied by the static friction is F1. It is not necessary that it will always be mu s upon n, because mu s upon n is the limiting force. So in order to stop this, the equal and opposing force has been applied by this surface, and that point is equal to F1 in the negative direction. So this is a very important concept that the students should understand in order to keep the concepts clear. So let's have a review. Now when we talk about static friction, say suppose this is your object of mass m and this is a surface. When a force F is given, if this F is less than mu s upon n, that is the upper limit of static friction, then the force that this surface is giving is simply F in the opposite direction. So you have to keep in mind this particular point. Now when F is greater than mu s upon n, then the force that is applied due to this is just simply F frictional is equal to mu s upon n. Only then they give a force of mu s upon mu s into n. Mu s into n. So this is the required explanation.